Hello, my dear learners. Welcome you all to the course on Signals and System. This course aims to develop basic skills in Signals and System area. Also, this course aims to achieve the basic problem solving skills for competitive examinations. Okay, so let's start the basic about what is mean by signal and what is mean by system. Let us understand the meaning of that signals and system. So here a definition is there. A signal is a set of data or information. So anything which conveys a data or information, we can call it as a signal. Okay, so the information in a signal, it has some pattern. Okay, let's see some examples of signals that we encounter in our day-to-day life. So first one is recording of speech. So whenever we talk, the pressure in the environment changes with respect to time, so that can be captured and recorded as a signal, and it is presented over here. Suppose if I pronounce a phrase "should we chase," and I'll get a signal pattern like this. So the first one, you can see over here, if I pronounce word "should," I'll get a signal pattern like this. Then if I pronounce "we," I'll get a signal pattern like this. Then the word "chase." Okay, so therefore this is a signal, and this signal conveys an information. So this signal conveys an information "should," and this signal conveys information "we," and this signal conveys information "chase." So as we saw as a definition, so signal is a set of data or information. Okay, so let's see one more example. This is a pattern of our heart activity, which is called ECG signal, that everybody knows it. Okay, so in ECG signal we have different variety of informations. If you look over here, we have P, Q, or S, T. So each peaks and valleys conveys very rich information about our heart activity. So if suppose if the peak here over here in the letter P, suppose if I get straight line, then doctor will examine the heart activity of your heart, and he will suggest some medicines, some wrong activity of a heart is going on. So you need to take certain tablets, and you get cured. Okay, so this one of the most versatile example of signal that we see in our day-to-day life. And third one is example of signal is called a monochromatic picture. Sorry. A monochromatic picture is an example of a signal, whereas this is a two-dimensional signal f of x comma y. So we'll see what is one-dimensional and two-dimensional signal in little later. So this is a two-dimensional signal where monochromatic picture, here brightness will vary with respect to the location. So if you see here in this hand, it is high brightness, the brightness at the head and bunion, so the brightness is 0, almost it is dark. So this is a representation of an image in two-dimensional, so where each location corresponds to the different brightness level. So this is an example of two-dimensional signal, monochromatic picture. So whereas the signal we saw here, the ECG signal and speech signal, these are all one-dimensional signal. So what I mean by this one-dimensional and two-dimensional signal, that we will see now. excuse me. So I mean the one dimensional signal I will represent like x of t. So x is any function where t is an independent variable. Suppose I have an ECG signal like this. Okay, so with respect to time my amplitude gets varies. Okay, so this with respect to time my amplitude gets varies where t is an independent variable. T is an independent variable. So this is one dimensional signal, whereas a two dimensional signal, the image f of x comma y, so we have a two dimensional representation. Okay, so with respect to this x is a location, so my brightness at this place will be something, this place will be something like this, and with respect to y location I have different brightness level. So the image is represented as a two-dimensional picture like this. So image is a two-dimensional signal where x and y are independent variable, whereas one-dimensional signal have only one independent variable. So now let's discuss how to represent a given signal, how to write a mathematical equation for a given signal. Suppose my signal have a pattern like this. Okay, so this is x of t, I have amplitude 1 and I have time t. This will goes to infinity, this is origin. How can I write a mathematical equation for this signal? So for t less than 0, this is 0. You can draw in a different kind of color. So how can I write mathematical equation for this signal? So my amplitude is 1 for t greater than or equal to 0. For t greater than or equal to 0, my signal have an amplitude of 1, whereas my amplitude is 0 for time less than 0. Okay, this is quite simple. Suppose if I have a signal like this, this is x of t, this is the independent variable t, then I can write a mathematical equation. This is origin. Let's say if the slope is 1, then I can write a mathematical equation x of t is equal to t for t greater than or equal to 0 and 0 for t less than 0. So for t means whatever the value t, you will get that value as x of t. If t equal to 1, you will get x of t equal to 1. If t equal to 2, you will get x of t equal to 2. T equal to 3, then x of t equal to 3. Okay, so this is these two signals or a simple signals that we can write mathematical equation easily. So there are complex signals that the mathematical equations are very rigorous. Okay, but though it is complex and still we can write a mathematical equation, and generally we call this a signal as step signal, and this is ramp signal. Okay, so far we discussed what is mean by signal and two examples of signal and how to write mathematical equation for a given signal. Now let's pay attention to what is mean by system. Let's consider I have a black box of a system. This is a box and I have input and I have output. Suppose I have a signal like this, x of t with respect to t. Then I want my signal to be like this. Okay, then I use some systems and I will give some inputs to the system in such a way that this signal has to be modified so that I will get this signal. Okay, so what you are doing some modification on the signal to in order to use for our purpose. So that's you are doing some rigorous some modification on the signal. Let's see an example in our day-to-day life. Let's take a mixie in our home. Let we put it in some solid form. Let's say this is signal. Then I will obtain the solid form into a powdered form. Okay. I'll get this signal in a powdered form. So what I done is I have converted the solid kind of signal into a powdered form. Okay, so I am doing some manipulations on the signals in order to convert into a suitable format. So there we use some systems. Okay, thanks for watching.